Well, everybody's getting organized. My name is Richard Worsfold. I'm a Director of Business Development at OCE, and I'd like to welcome you to our Aerospace Forum. And like I said, would you come in, please, sit down. We have an interesting session for you today. It's purpose-built aerospace systems, and I will introduce you to our moderator, Larissa Beach. Larissa and I have known each other for many years, and she's one of the co-founders of the Neptec Design Group. And I think it's more interesting to listen to these people than me. So Larissa, would you like to come up?
Thank you for the introduction, Richard. Good morning, ladies and gentlemen. Thank you for joining us in this panel, Purpose-Built Aerospace Systems. This panel will examine the innovation and development of the specialized technology needed for aerospace systems designed and built for a particular use or with a specific goal in mind. Whether the system is built for space, specialized aviation tasks, or for pleasure or sporting purposes, the outcome goals are not always the same as they would be for standard aviation. It's my pleasure to introduce to you the panelists today. For their full biographies, could you please look at the Discovery website? They have pretty good descriptions of all of them. Our first panelist is Mark Arujau, Chairman of the Board of Unmanned Systems Canada. Mark has diverse experience in defense, government, industry, and the not-for-profit sector, spanning over 40 years, characterized by leading change. Mark closed his military career by being selected to be the first commandant of the Canadian Forces Experimental Centre, where he established the first experimentation program for UAVs, and which is the foundation for the subsequent use for by the Canadian Forces. Our second panelist is John Dunlop. John is a product line director responsible for space robotics at McDonnell Detweiler and Associates Robotics and Automation Division in Brampton, Canada. John has 30 years of industrial experience in roles including engineering, project management, and business development, including 10 years as program manager for MDA's Space Station Robotics at Canadarm2. Our third panelist is Sébastien Fournier, the Chief of Innovation at SolarShip. Sébastien manages SolarShip's R&D network. He coordinates world-leading institutional and industrial partners and suppliers in strategic research areas that reduce the cost and risks associated with SolarShip's commercialization strategy. His expertise ranges from material sciences and polymers to biotechnologies with international experience. Our fourth and final panelist is Brandon Robinson, the President and CEO of Horizon Aircraft Incorporated. Brandon graduated with honors in mechanical engineering from the Royal Military College, after which he was fortunate enough to be selected to fly the CF-18. With a technical mind and an eye for design, Brandon's driven nature and lead by example style helped to strengthen the Horizon Aircraft team, keeping it aligned as they move towards building a better future in aviation. Welcome, and thank you for being here today. Now each panelist will present their project. At the conclusion of all the presentations, we will have time for discussion and audience questions. To begin with, I'd like to invite Mark to the podium.
Thank you, Larissa. It's great to be here this morning. I'm representing Unmanned Systems Canada, which is a national not-for-profit association established 13 years ago. And we have basically built the ecosystem for what today is known as the UAV industry. Probably our most significant role in that has been actually as the co-chair with Transport Canada for the last 6 years developing the regulations. So that has enabled a whole lot of things to happen, and that's the subject of the conversation for the next few minutes. So manned aviation took 15 years to go from concept to where we're actually seeing things being accomplished. Mail delivery was one of the first things, But then there was surveying, certainly of Canada's north after the First World War. And then after the Second World War, that's when really passenger transport took hold, and we've had a rapid growth in that industry. But it's all been about moving people. And only in the last few years we figured out that if we took the people out of the manned platform, we can do everything else except transportation. And that's what I would suggest to you is for the theme of this is no longer an aerospace industry, this is an Internet of Things industry. It's transforming the use of aerospace technology into something completely different across almost a limitless number of applications that we're seeing today. So let me take a look at what the enablers are. It's really this simple. You take this is a computing platform, it's a multi-band communications platform, it's an image processor, and you can get this thing airborne to do all kinds of things. But if you attach 100 kilograms of Markaruja to this with all of the benefits that go with it, like windows, doors, a seat, climate control, it becomes a transportation problem. If you just put this up there and remove me from this, you now have all kinds of things you can do that were previously not feasible. So that's really my pitch is, it's a transformation into the Internet of Things that we see into the future. So let's take a look at a couple of examples here, just to give you a sense of what's happening today. So the OPP, many of you wouldn't know this, the OPP was the world leader in establishing the use of UAVs or drones in accident reconstruction. They've worked at this since 2007. I can tell you exactly the day that Constable Mark Sharp from Kenora posited this problem to the world, and we started working on it. Today, Canada's first responders are the world leaders in the use of this technology. What's the benefit to you? Well, there's three things. The first of all, the airborne view of the accident scene gives a far better detail that are not possible from ground-based traditional analysis. The second thing is, it's far faster. They show up with a device in the trunk of the car, and the highway is opened up in typically half the amount of time that traditional methods use. And the third thing is, if you need to go to court, it's now established that Canadian courts, prosecution, defense, and the judges all see that imagery of a crime scene, if you will, at that point, from a common perspective. And that has been now widely accepted by the courts as a technology that they appreciate. So we have aggregate mining, this kind of work where you take 3D renderings of aggregate pits. This is now in everyday use in the construction industry in Canada. Bridge inspections. I was talking to a Canadian company the other day. They've just got a contract to do bridges in Norway. There are 1,500 bridges in Norway, and they all need to have work done. And the way they figured it out is there's a 3-year warranty on the bridge. 2 years before, or the year before the warranty is up, they get in there and start going through so they can do a warranty claim. And talk about warranty, insurance industry, rooftop inspections, far more safe and effective done in this fashion than traditional somebody getting on a ladder going up there, far more expensive and certainly not as safe. So all kinds of applications out there today. So I'm just going to focus a bit on one that is certainly seeing a development here in Ontario, and that is precision agriculture. What this depicts is that their satellite imagery has been available to the agriculture industry for years. We have meteorological data, we have graphical information systems to give us an idea of the drainage systems, and now we bring in a new tool, and the point of that is that we're very much seeing now the development of data analytics as part of the industry. How do you merge these different sensing devices together to give the best information to the agronomist, to the farmer, to make decisions about their crops? The big difference here of what the UAV brings is this. We're talking about a small suitcase-sized device, clips together, very sophisticated avionics and software. These typically will do a 250-acre field in about 30-35 minutes of battery life, and they will produce a very sophisticated output from a camera that is about 1 kilogram on the left-hand side, a multispectral camera that is now coming down dramatically in price. I was told the other day that particular camera was $16,000 last year. It sells for $5,000 this year. Gives high performance, multi-band performance, 250 acres. Now here's the trick. Well, this is all automated flight planning. It's in the suitcase. You plug in the coordinates of your field. It takes in the wind data that it's got there, and it automatically programs the UAV to fly that. In this case, let's say a representation of a 250-acre field to do whatever the mission requires in terms of gathering the data. But at the end of the day, you end up with something like this. Those red dots there are individual leaves on a corn plant. So we're now gone from 3-meter satellite resolution to 3-centimeter resolution, and that's a 4 orders of magnitude increase in the number of pixels you now got to digest and integrate with their other data. So hence back to my point in data analytics. But the Internet of Things theme works from this premise. We can now, at that resolution, program the prescription for the sprayer, the combine that's going to go out there, which also has differential GPS in it, takes that prescription now, and at that level of resolution, does the treatment for that agricultural product. I just use this as a different technology. LiDAR is now coming down. This is laser imaging. The point of this is that once you get into certain sensors, you might be flying to do an inventory of a forest, if you will. But as you're going along, you can also now do inspection of right-of-ways for the hydro company. There's many other things you can get out of that sensor data and provide that out of a database parsed out for different customers out of one sensing mission. Now, this is the technology side of things. But as you well know, there was a lot of pushback on the social acceptance side, the public license to be able to do this work. And I want to tell you this quintessentially Canadian story. May 2013, the world's first successful unmanned vehicle search and rescue, done by the RCMP in Saskatoon. May, out of Saskatoon, it was nighttime, snow out there. Definitively, this guy would have died if he hadn't been picked up at 2:30 in the morning by that UAV. So for the media, fabulous. But we were under a lot of pressures in industry still to explain issues with regard to privacy, all of those things that the public had legitimate concerns about. But the media story and the public perception changed overnight when Constable Green went and spoke with Katie Couric to the world's media. And the media took attention, and today the media has been very helpful in getting the message out as to what the industry is and is not about. So some of the challenges. Today we fly in visual line of sight. That means practically out to a few kilometers. Hopefully by the end of this year, we're going to crack the regulatory nut on how to start moving forward with beyond visual line of sight. We're starting to talk about linear infrastructure of thousands of kilometers, of pipelines, of hydro infrastructure. BSNF in the United States is now flying down the railways to determine the condition of the rail infrastructure. The possibilities are huge. The economic potential is huge, and this is an exportable capability. So that's a challenge yet to be overcome over the years ahead. Data analytics, I've already made that point. It's no longer about what is it that you're flying, it's about are you getting the right information to make a better decision for your end customer. Certainly performance or reliability continues in sensors and platforms, and that remains a safety public confidence issue. And finally, the recreational user, I read about that every day because I get the daily Transport Canada incident reports, and we still have challenges with folks either flying commercially without a license, which is illegal, that's $25,000 off the top, or the recreational person who ends up flying near an airport and just doesn't kind of think through what the consequences may be. So this is the incredible growth of the industry. Last year, 2,500 permits were issued by Transport Canada for commercial operations in Canada. And look at that. So we've hit the inflection point. And what that means is we've created about 1,000 businesses in Canada in the last 3 years in this sector. And I'll challenge folks to say, is there another sector that's had that kind of dramatic growth in Canada? And some of them are actually making money. So with that, thank you very much. Look forward to the Q&A, and for those who want to understand the sector, get into the ecosystem. Our annual conference is in Edmonton, 1st to the 3rd of November.
Thank you very much. I'm sure this has generated a lot of questions, and we'll have questions at the end of all the panelists' presentations. Next is John Dunlap. Oh.
Excellent. Good morning. A pleasure to be here, and hope you'll find this interesting. I'm John Dunlap, and I work at the Robotics and Automation Division of MDA, which is in Brampton, Ontario. And what I'll be talking about today, first in context, but it's ultimately the space robotics work that we do that's the core of our business. So as where we fit in the MDA Corporation, the slide shows the different sectors that MDA is involved with, between the telecommunications satellites, dealing with the data that's derived from them, and then in the bottom right corner of the slide is the robotics and automation, and that's the area. Now we, in the late 70s and early 80s, developed the Canadarm for the space shuttle, and then in the 80s and ongoing today is the robotics for space station. So definitely purpose-built equipment. Very much an engineering challenge, less so on the production end, but more so on the engineering end. The challenges we faced are in some ways common, in some ways very unique with the environment and the remoteness of the operation. And currently today, the ongoing effort in the space station program is maintenance of the equipment, which happens, and control of operations. So the operations effort is planning operations and operational analysis, developing software files that control the operation of the robotics on space station, which are all controlled from either the Canadian Space Agency facility in Saint-Hubert, Quebec, or Johnson Space Center in Houston. In general, the space robotics work that we've done, this chart is trying to identify the customer community we serve. Along the top would be the civil or institutional customers, and then the middle band would be the people that we've dealt with in terms of industrial commercial customers. And in order to get the Canadarm done, more than 80%, in fact, I think it was over 90% of the expenditure on investment in Canadarm2 was expended in Canada. And there's over 500 companies that were involved in the Canadian companies that were involved, everything from freight to developing complex subsystems. A handful of them are identified on this slide. So the Canadian, we leverage the same supply chain in some respects that the aerospace industry would, and obviously in some cases we have very unique needs to build the space robotics system. Additionally, both in the space station and the research and development that we do in other applications, we've had collaboration with different academic institutions across Canada. So some of that's for guidance, navigation, control, some of that's for material sciences, a pretty broad range of applications as where we've seen the space robotics branch out to. Currently we're active in the nuclear and medical areas, both highly regulated industries, both seeing some of the similar constraints that you have with planning space operations apply to medical and nuclear. So some of the practices and approaches that we develop for space station apply equally there. Where do we go from here? So a bit of a complex chart, but the areas that we're pursuing, going from left to right, commercial opportunities in space. So one of the big things that a couple of the things that come here is geocommunication satellites and life extension of geocommunication satellites, which can include refueling and or upgrading the capability of geocomsats. And I think we've heard a lot in the recent years about large constellations, largely of LEO satellites, to build communication networks. So there are many, many satellites, and we hear occasionally about concerns about orbital debris and the significance of it and how it will be dealt with. And there are robotic measures. It's not the only approach, but one approach is robotic remediation of orbital debris. On the space exploration, obviously Space Station and Canada's got a commitment on Space Station to 2024, as does the US and some of the other international partners. And there's increasing talk now about where do we go from there. Do we go to the moon? I think it's agreed the ultimate destination would be Mars or human presence on Mars, but you've got to take steps to get there. So use the space station as a proving ground and learning area, and then go in the lunar vicinity, perhaps operations on the moon, and then step out to eventually to Mars. And then all the while, technologies that have been developed for space can spin off either directly or variants thereof for terrestrial applications, as I said, in medical and nuclear, and also in industrial automation, security. So there's lots of places for the technology developed for space to be applied on Earth. I think there is a video. I'm not sure if Kemal. Okay, well, not to worry. The video was to be showing a recent operation of the Dexter, which is the second robot that Canada provided for Space Station, performing a change out of the camera system on the Canadarm2. And the kind of interesting thing here is the designing for maintainability, and all the operation was controlled from CSA in Montreal and from the Houston facility. So quite challenges to foresee that. We've talked things before we got up here, things like driverless cars, and there's sort of a cultural apprehension, if you will, towards some of those technologies. We ran into a similar apprehension with control of robotics from the ground. You know, will the onboard crew be comfortable with control of automation from the ground, other people in control when they're asleep? And it was a huge cultural hurdle to get over, perhaps more than a technical hurdle. Technology was relatively straightforward, but ensuring that you have all the safeguards in place and convincing people of the safety of the operation is a huge step to take. With that, I think I'll wrap up and look forward to questions afterwards. Thank you.
Some interesting thoughts on how you take a basic technology and create an innovation for the future. Very good, thank you. Sebastian, if you could come to the podium, thank you.
Thank you here, everybody, for coming. Thanks, Richard, for the invitation. So today what I'm going to talk about is about Solarship, what we are, and why we're here. So this 21st century, pretty much everywhere, every large city in the world is connected. And we could fly pretty much anywhere we want within 24 hours, arrive from one major city to another major city. That being said, if we just look at the Canadian context, we really look at 70% of Canada, the northern part of Canada, has no year-round access. We all focused around 100 miles close to the US border, and there's a great network of roads there, but as soon as you go further up, there's a lot of issues there, and we're not alone. If you look at the rest of the world, Africa, Brazil, and a lot of South America, northern Russia, Western China, and big part of Oceania, there's about 1 billion people living in areas that don't have year-round transport. So you can imagine with 1 billion people, there's quite a large demand and really little supply there, despite a few current transportation. So we've got airplanes, we've got helicopters, trucks, and trains. But trucks need roads, and some of you may have seen the top picture here in Canada, where a few months ago there was another one of those on the news where the ice roads keep melting, and they can't support trucks. So what used to be a very efficient way to go without roads in the northern part of Canada doesn't happen anymore. It doesn't look good for the future. In Africa, there's no ice. However, heavy rainy seasons provide those dirt roads inoperable. So there's a lot of issues with roads and keeping them maintained. Helicopters, great invention, amazing, but it requires a lot of fuel, lacks range, and there's a lot of maintenance and sophisticated maintenance required, and for remote areas it's a little difficult. Trains obviously need tracks, and planes need fuel and runways. So the goal really for Solarship was to, could we create an air transport system that doesn't require roads, doesn't require runways, doesn't need infrastructure when it gets there, and doesn't need fuel. And on top of that, if you can make it take off and land from a very short, flat surface, the size of a soccer field, even better. So that's what got us started. And for the concept, really, we took the great Canadian invention that the bush plane has been to service some of those parts, and using the dynamic lift of that aircraft, or all other aircraft, and using an airship, combining an airship and static lift to that to allow the creation of a hybrid aircraft that can take off and land in extremely short distances. So that's really the whole goal of where Solarship exists. One thing just to let people know, we are an aircraft. We do have buoyancy-assisted lift, but we're heavier than air, so we take off like an aircraft with just a single pilot, we land like an aircraft, and then when our cargo is removed, we're still heavier than air, and we are still on the runway like an aircraft. So there's a lot of issues with airship. Our goal is really to stay within the aircraft category, but using that buoyancy to provide extra load capacity and really counteract some of the weight for the solar panels we put on board and the batteries we use. So the various technology I just talked about, the bush plane is key to us. We obviously use cloth, very high-tech fabrics that is used in space exploration, also used in competitive sports like competitive sailing, very, very tough fabrics. Obviously, solar panels is a huge development in solar panels, renewable energy, so we leverage that. And last but not least, using batteries. Companies like Tesla Motors have been great at really developing and making batteries more energy efficient, and to be able to pack as much energy as the smallest amount of weight possible. So we basically leverage all those technologies that are evolving on their own and trying to implement them, to integrate them all in one single aircraft. So our first prototype was in 2009. We started flying remote control to really test the wing concept to make sure it was controllable. We then put a pilot in it in 2011. We had first piloted a flight, a few changes on the controllability. There you can see. Third prototype, we partner with a Canadian company, Zenair, that's making a lot of bush planes, and they had the very brilliant idea of, why don't you rip the wing off of our aircraft and put your wing on top of it and see how it flies. And after obviously lots of tweaking and studies on improving making sure the center of gravity and all the other centers of buoyancy are rightly located, we were able to really have this first aircraft that could take off and land within 100 meters. So when that was done, we really took it to the next level. The previous aircraft was about 10 meters in wingspan. Then we started scaling it up, where using really the buoyancy and adding the electric nature to the aircraft. So in 2013, I believe, that was our first electric flight, completely electric flight. And then we started flying solar electric thereafter. And then we recently demonstrated that even with that solar electric aircraft, we could still land and take off in a soccer field. And if you go to our website, you can see plenty of videos of that. So main application here is really looking at disaster relief. That's kind of a big application, but air trucking is really where we want to go. The 20-foot container, the little red box there, is really the red blood cell, I would say, of globalization. Without that 20-foot container, China wouldn't be where they are today. The ability to really export everywhere in the world through that container has been key for everybody. The fact that it's intermodal has been also a key aspect. So 20-foot container can go on boats, on trains, on trucks. Aviation is really the only mode of transport that doesn't easily take that 20-foot container. So our goal is really to add that and to be able to take it to remote areas. So if you plot the transport cost per ton mile or ton kilometer versus the speed of transport, you'll see that ship and sea transport is really low cost and low speed. And then if you move to land transport, to trucking, you go to a little bit higher speed and a little bit higher cost. And aircraft transport, or air transport in general, really has high speed and high cost. So von Karman in the 40s really discovered that there was this kind of efficiency limit that below which lines you cannot really go. But if you see here, there's a very, very large gap between the aircraft, the speed of an aircraft, and the speed of a truck, and the same type of gap in terms of cost. So really by adding buoyancy to aircraft, decreasing the cost to operate, also decreasing the speed, we only fly at around 100 kilometers an hour, we can really access the gap that has been researched to be definitely in the $1 trillion space. So not everything is roses. There's like big challenges, and I'd like to share the 3 main ones that prevent that transport capability gap to be black. First off, lift is definitely not a challenge. We've got massive volume, we've got massive lift, and massive momentum. That being said, though, controlling that momentum, especially as you go for larger solar ship, that becomes challenging. You can imagine we fly at around 100 kilometers an hour. So as you scale up the aircraft, the speed doesn't really change, but you have a lot more forces on control surfaces that you need to actuate to be able to control the aircraft. So those are ongoing challenges where we're collaborating with companies. We welcome more collaboration to try to improve controllability of such aircraft. The second one is really about the buoyant gas we put inside, helium. Most of our customers, when we come to them and say we're going to have an aircraft that doesn't use fossil fuel, they're ecstatic. And then when we tell them that instead we're going to have a fossil gas, then they're not so excited anymore. Helium, it is indeed a fossil gas. It has a finite amount on the planet. It's coming from radioactive decay of uranium. We can't create it, at least until we master fusion, but it's very expensive. True, we don't consume it, but there's leakage. So it's like your tires. You need to top up your tires from time to time, and here not with air but with helium. So replacing that with hydrogen, which is a gas that's renewable, that you can generate on site anywhere from water through electrolysis, is really the key of the future. Here in North America, unfortunately, there's been this little event that happened in 1937, I believe. Most of us weren't born at that time, but it still resonates today. And despite the fact that there's a lot of other places in the world, like Europe, that fly with hydrogen tourism all the time. So we want to work with the regulators to try to take that forward, but that's another one of the challenges. And the last one is really how to extend the range when there's no sun. In northern Canada, in the winter or even in the summer, there's a lot of sun, but not necessarily a lot of energy because it goes through a lot of atmosphere. So how do we develop new range extenders to access even further remote places? So once we figure that out, then we'll come back to Toronto and look at improving commuting and transport issues here, landing on Bay Street or in the middle of a soccer field at U of T. But I'll leave it at that for now. Until then, check us out at solarship.com. There's plenty of videos of us flying, and I'll be happy to answer any question. Thank you.
some interesting view of Toronto in the future. So our last panelist is Brandon. If you could do your presentation, thank you. We have a competition here, sound-wise.
It figures. So I'll be competing with the UAV. I think I'm comfortable with that, but if it's not loud enough, just let me know. So before I get into all the cool things that Horizon Aircraft is doing, I'd like to first talk a little bit about the future. So recently, my wife and I had a new son, Ethan. He's now 7 months old. Really cool little guy, just crawling around and chewing on everything that he can chew on. But I speak to all the parents in the crowd, I'm sure, when I say that when you have your first child, things fundamentally change. So you start thinking a lot more about the future. The news gets a lot more scary. And for me, I started thinking, you know, what can we do? What can I do specifically to make this world a little bit better place to start protecting the future for my little fella? And I like to take that theme and bring it to Horizon Aircraft. So we believe very deeply that the future for aviation is very bright. It's a lot cleaner and it's moving towards electric. And that's what we're trying to do in an uncompromising fashion. So building a really cool airplane with uncompromising specs, but at the same time, we're making the world a little bit better place, we think, along the way. So without further ado, this is what we'll be talking about, a little bit about the team and our journey along the way. But we'll focus on the cool stuff, the design, and that'll generate some questions, and then quickly the plan to bring this to market. So there I am. Joined the team a little bit later to coordinate a bunch of really smart engineers. Fighter pilot background, did the Top Gun course. Mechanical engineer and licensed to be dangerous on the business side. Great career in the Air Force, and then was recently doing procurement in Ottawa for 3 years. So if anyone's done a tour in Ottawa after flying a jet for 10 years, maybe think twice about that. But it's been eye-opening, let me say. Brian Robinson, my father, the genius behind the design of the X3, which we'll introduce in a minute. A lifetime civilian pilot, has been flying since he was 14 years old, has been building airplanes since he was just probably about 14 years old as well. A mechanical engineer, custom aviation genius through his custom engineering shop, basically working on solutions for people with airplanes where no one else can solve them, so he likes to do that. Also complex manufacturing experience in the pharmaceutical industry, all the way from designing cool machines to produce surgical stents all the way up through to manufacturing. The rest of the team, I won't go through their biographies quickly, you can check them out on the website. Key takeaway is we have a team members that have experience in all facets of aircraft design, all the way through to initial thinking up the idea to detailed design, production, testing, all the way through. One of the individuals has actually designed, built, tested, flown 2 of his own designs, Mr. Kirk Creelman. So our story starts with that beautiful airplane that you see there on the screen. So that's an old 1947 Republic Seabee. But it had a problem. So my dad's been flying this for a long time. It originally came with a 215 horsepower Franklin engine. Now I don't know if you can recognize, but you can put a lot of stuff in that airplane. 215 horsepower is just not enough. So one of the first modifications he decided to do was rip it out and put a Corvette GM V8 engine in it. Took it from 215 horsepower to 350 horsepower. He had designed his own gear reduction box, reprogrammed the computers, wiring harness, all that sort of stuff. And that's only one of about 50 modifications that are now currently on the airplane. So he's a bit of a tinkerer. And basically, he took that airplane design as far as he possibly could. So that brings us to the next, where we are right now. So there it is, sitting on our hangar floor. It's all produced, everything's great. If you want to buy one, you can go and see our kiosk and order it. Just kidding, of course. So that's a cool rendering of a design that is 75% complete. We have a 25% scale test model that's flown and can prove all of the stuff that's all of the stuff that you get out of your computational fluid dynamics modeling. And it also proved the hydrodynamic handling characteristics. Because it's an amphibious airplane, it can take off and land from any surface. So think remote locations, any 1,000 feet of water, snow, grass, ice. Of course, it's at home in any airport as well. And that's where we're at right now with that design. And where we're headed, the future looks pretty bright. So we're looking to license it first under the experimental or amateur built categories to get it on the market, generate some revenue, and then move into certification, after which it really does open up a pretty wide number of missions that it can perform. So anything from search and rescue, surveillance, northern resupply, disaster relief, very good at remote operating locations. And that's because of its performance characteristics and the way it's designed. So first of all, you can see performance is pretty good. We're getting 300 kilometers an hour, 1,500 kilometers range, and it can carry 450 kilograms in a hybrid power system configuration. So we'll get to that in a second. But it's pretty good specs, and it's a very good utility aircraft, will be for going places and doing stuff. Near and dear to my heart, fighter aircraft cockpit. You know, without the prop in the front there, I mean, it really does connect you with that visceral sort of feeling of flight. And it has great visibility in the computer. You know, sat in the cockpit and looked out, and it's pretty awesome. We have some patents for the landing gear design that allows the airplane to land on any surface. So like I said, snow, grass, ice, water, any hard surface with the landing gear in any position. So this is a big deal for amphibious airplanes. Normally, if you land with the gear down in water, that's a bad thing. Airplane flips over and you're swimming. So 50% of all serious amphibious aircraft accidents are due to that exact thing, where the pilot forgets, leaves the gear down and lands in the water. Our aircraft, that will not happen. And we proved that through our 25% scale model, which is pretty big, 13 feet wingspan if you've been over to see it. The rugged design, any amphibious airplane is built for landing in the water, and that has to make it tough. So it instantly opens up remote locations, accessibility, that sort of thing. So tough airplane, even though it looks awesome, and all powered by a 700 horsepower hybrid electric system. So there it is. You see on the end, you got a electric motor, 200 kilowatts plus. So we're talking over 250, 300 horsepower. Then we have 200 kilowatt generator contributing back to the battery system, all hooked to our GM V8 LT1. So you can think of it as two separate redundant systems working together. Hybrid is especially useful as an airplane power system because of the redundancy. So in our design, either the electric system or the conventional power system can both power the aircraft independently should it so require. Put them together and you got a lot of horsepower to go fast, to get where you need to go quickly, or to haul a lot of stuff around. So safety, redundancy, and efficiency is the third. So short missions, we've shown that we can save up to about 30% in fuel by leveraging the power that we contain in the batteries, which are pretty advanced. So all that together is a pretty cool power system that brings a lot of horsepower and performance, but also is bridging the gap to a future of electric flight. So our operational plan to get there, building a prototype is going to take us 2 years to finish the full-scale design and produce the first aircraft, after which the next 2 years will see us build kind of 8 more and then get into high-volume production. Not too interesting there, but the future does look pretty good once we set up that high-volume manufacturing. And this is really the secret to success of the whole thing. So we have that highly skilled team that is experienced in all facets of aircraft design, with a plan based on experience, been in the industry a long time, with a disruptive, innovative product, that hybrid power system attached to an airplane that's very versatile, utility-based, that can really opens up Canada and other austere operating environments very well. Global market appeal, of course, anywhere where there's a nascent general aviation infrastructure. We're talking China, India, anywhere. Of course, the northern territories in Canada as well. Platform very suited for that. Also, of course, a platform for growth as well. So I'm supposed to click on this. Oh, let's go back. So if we can cue it up at the back, cue that movie up. So that's what we're doing at Horizon Aircraft. So we believe very strongly that the future is in electric aviation. But until we get to such point where we can actually build practical, pure electric airplanes that can fly, we believe there are a lot of advantages for a hybrid electric power system, and especially an airframe this versatile. So we're doing our part to build a better future, not only for the aviation industry, but for our children from whom we've borrowed the planet for a little bit. Thank you very much.
Thank you to all our panelists. I just have a few general questions addressed to all the panelists, and then we'll open up the floor for questions and answers. We've seen some very innovative approaches, technological approaches. If you have any further comments to make on how this fits in and differs from commercial aviation and where you see this going in the future. So anybody have a comment?
From Solarship's perspective, we don't see any competition with commercial aviation. As you've seen, we're not going very fast. So unless someone wants to take a week to cross the Atlantic, we don't see a conflict. I think from our perspective, we're just creating this new niche market that the commercial aviation isn't targeting because there's a lack of infrastructure and runways. So we're just basically creating a new market. So from our perspective, it's just, an extra market that's just created.
Okay.
Yeah, and from Horizon Aircraft's perspective, I mean, we've seen some great leadership actually from the commercial operators. So we see Airbus with the EFAN, and that honestly, that's inspiring for us. So we don't see a competition with commercial aviation. We see partnerships with commercial aviation kind of being the way forward. Working together to bring battery technology forward, driving that innovation and electric motor technology, getting us to that place where we can get to a place where pure electric flight is not only a possibility, it's an actual reality.
Good, thank you.
So in the early days, which is 7, 8 years ago, if you approached certain organizations that were flying conventional aircraft and you wanted to talk about UAVs, there was some suspicion from the pilots that they were being displaced out of a future job. And that, in fact, has changed significantly in the last couple of years, where existing aviation companies are embracing the technology to get to new markets, and in fact building upon their expertise because they have the safety culture, they have the understanding of the aviation environment. But ultimately, most of the applications that certainly I would posit to you are non-aviation. They're developing new markets, new things that weren't conceivable in many ways to make the planet a better place. Less consumption of input, higher yields in terms of our output across any number of industries. So,
Thank you. Just one further thought. We saw a map of all of the remote areas in the world and in Canada as well. And aviation is one aspect of accessing remote areas, but how do you see these technologies and developing? What technologies do you see developing to improve our life on Earth in remote areas and to help the people that are situated in the remote areas?
I'll start with that, I guess. One of the ongoing, I mean, obviously there's remote control of robotics that we've used that has applications on Earth. Another area that is of a lot of interest, Canadian Space Agency, is the health of the crew on orbit. And I know, Larissa, that NEPTEC did studies as well on behalf of the CSA for advanced crew medical systems. And there's a very easy analogy to healthcare for remote areas, whether the remote area is a rural delivering healthcare to rural settings, or whether it's battlefield settings as well, where again, you can't have all the facilities of a metropolitan hospital in a very remote area. It doesn't work, but there are areas to deliver the care.
The bush aviation analogy is just perfect. The conditions of Canada created that. We're still the world leaders in that, and it's exported around the world. And the unmanned systems business, I think, is exactly in a position to follow that model. But we have one challenge in Canada, and that is we have a difficulty getting the investment capital that will make that happen. So I'll give you just one example. If indeed for the nation's good, we need to get that energy pipeline moved. Let's say it's an $8 billion project, whatever it is. If we can use this technology to demonstrate that there's a better way to retain the integrity and the capability of that pipeline, what's the opportunity cost, and how do you bring that investment money? And there's innumerable examples that I could give in terms of just linear infrastructure, let alone environmental monitoring and so forth. So ultimately the challenge for Canada is we've done it before, we've exported that expertise around the world. Bush Aviation is a great example, but we need to close the investment gap to bring the money to reduce the risk and understand how to take that business case to customers around the world.
Thank you.
Yeah, I think, Mark, I mean, that's just an excellent point. And I think the leadership role in exporting our expertise is ideally achieved not only through private investment, also, like I said, partnerships with larger companies that, there can be some reciprocity there with the technological development. Smaller firms, a bit more agile, can move quickly on accessing certain technologies and assessing them, and driving innovation that way as well. So, excellent point.
Thank you. So what I'd like to do is open up for questions from the floor. There's 2 microphones at the back. If you can't access a microphone, we can bring one to you. So if you can approach either one of the microphones, you can either address it to the entire panel or to a particular panelist.
There's got to be somebody out there. There's a question. I know somebody has a question. Who's going to be first?
So I have a question. Brandon, we'll put a deposit down on your airplane now. I mean, Elon was brilliant with that. Can we do that?
Well, I was speaking with JB Straubel yesterday, and there has actually been quite a bit of interest. So we're thinking about opening it up. We want to get a little closer to having that first prototype done. We're confident that it's going to work, and of course everything is looking that way. But maybe I should be more serious when I said, you can sign up at our kiosk. Maybe the next time we come by here, you'll be able to sign up at our kiosk.
Maybe we'll be able to fly around up above everybody.
Yeah.
Anyhow, the whole topic of innovation and technology and the different technology is such a fascinating topic and holds such promise for the future. Oh, you have a question.
We all know that there's a thing in Ontario called the Ring of Fire, and that's where we're going to have the mining future. And in the Ring of Fire, we're going to have temporary towns. What goes in has to come out. How is your technology going to be able to fit into that type of scenario? We're not going to build airports. We're not going to build runways. We're not going to do that type of thing. Yeah.
Sure. Well, I guess that's, I'll lead that one off. So as long as you have 1,000 feet of any flat surface, our technology, the X3, will be able to get in and out. So any flat surface, meaning a piece of gravel that's 1,000 feet long that fits a 50-foot wingspan, maybe a little bit of buffer between the trees, so maybe 70 feet, depending on how good a pilot you are. I might need 55 feet. But in any case, if you have water, a stream, anywhere close that's accessible, and that's where our aircraft can fit in, deliver some supplies. If you put in temporary roads to truck things up there, then of course it can land on any temporary road as well, helping out as a piece of the larger picture of that development.
Well, from a Solarship perspective, and we've been we starting operation actually just south of the Ring of Fire to demonstrate the feasibility of not having any road there. We know that the $1 billion road in coming out of Thunder Bay there, I don't know if it's going to be happening or not, but anything that can be brought in within a 20-foot container, which is, as I mentioned earlier, anything can get transported to a 20-foot container, is what we're going to be doing. So I only talked about the aircraft we're developing, but Solarship is actually developing the entire a self-reliant remote area logistical system that includes an aircraft, a hangar, and systems, and all that is being brought by the aircraft. So we'll have inflatable hangars that can be brought in the 20-foot containers, and all the different parts of the puzzles, as long as they fit in a 20-foot container. And that's a hard criteria that we put for any innovation we develop, is if it fits in the box and we can carry it, then you don't need any road. So that's our approach to that.
Okay. Mark?
So once you've got MDA's radar site imagery, you've got all of that other stuff, you want to do some detailed planning, and that's the perfect application for what's out there today. Is you can do the detailed drainage maps, you can do the environmental survey, you can plan out the infrastructure so that Sebastian Bowen knows exactly where to drop the load.
Okay.
Yeah, I mean, that's an excellent point. So a fused solution where we have, maybe taking a look at it with some space assets, Mark's UAVs flying around, taking a look and surveying the area. Sebastian's integrated logistics system being the backbone for getting the major amount of stuff up there. And then, the X3 shooting up and down, carrying some stuff that we might have forgot initially for...
Okay, well, thank you. We just hit it right on. I have a slight gift for each of our panel members. I would thank you very much for coming. Will you please give them a big hand? And lunch will be served out there in 15 minutes.